the first thing that we have here, this is the solution to the quiz question. This is what you needed to do, right? So what you have this box sitting on this incline that's inclined at 45 degrees. Draw your free body diagram. You have a normal force acting up. Force of friction, oddly enough, is acting up the incline, and force of gravity is acting straight down. You rotate your coordinate system so that your coordinates are along the incline. And then you have force of gravity. Since it's acting at an angle to your coordinate system, you break it up into FGX and FGY. You write the sum of forces in the y direction to find what the Fn force is. Write the sum of forces in the x direction. Find that the force of friction is equal to FGX. Divide both sides by Fn to find mu is mg sine 45 over mg cosine 45. Solve that out. You get mu is equal to 1. Okay? Piece of cake. I've done this a million times. It's insane. Okay, so questions that I was sent to cover in class today. Somebody asked me about problem number 17. So let's talk about chapter 6, problem number 17. And in this problem, we have a girl that pulls a sled along a level dirt road by means of a rope attached to the front of the sled. The mass of the sled is 40 kilograms. The coefficient of kinetic friction is mu k equals 0.6, and the angle between the rope and the road is 30 degrees. What pull must the girl exert to move the sled at a constant velocity? So how do we solve this problem? What's the first step?
Draw a picture.
Draw a picture. So let's draw a picture. Is this going to be a witch that's pulling our sled? Could be, but it doesn't need to be because it's not a magical person that's moving in frictionless motion. So we're pulling this sled at an angle. What's the angle that we're pulling the sled at? 30 degrees. So I have a 30-degree angle right here. So that's going to be the force of my pull, Fp. What other forces are acting on this sled? What else? Where does the normal force go? Guys, listen up. Straight up, normal force. We have gravity. Where does gravity go? Straight down. Any other forces? Where does friction go? Opposite the direction that you're pulling. Anything else? I certainly hope not, because that's all I have. So we have this force of pull, and that's kind of acting at an angle, isn't it? Should we rotate our coordinate system? No, that would make our lives a living hell. So what should we do when we have this force acting at an angle? Break it up into x and y components. So we'll have some piece that's moving in the x direction. Let's call that Fpx. And some piece that's moving in the y direction, we'll call that Fpy. Let's write Fpx in terms of Fp. What is Fpx relative to that angle? It's the adjacent side, so it's going to be Fp times cosine of 30. What about y? Fp sine of 30. Anything else we can do at this point? No, I think we've broken everything down as much as possible. So we can shrink our picture, move it off. And what do we do when we have forces acting in different directions? Sum of forces in the x direction and the y direction. So let's start with the x. How many forces are acting in the x direction? What's pulling it to the What's pulling it to the right? F pull X. Anything else pulling it to the right? Nope. Anything pulling it to the left? Friction equals mass times the acceleration in the x direction. What is the acceleration in the x direction? Why is it 0? Because it's moving at a constant velocity. Constant velocity means 0 acceleration. Okay. So now we know that Fpx minus the force of friction is equal to 0. So Fpx, and what was Fpx? Fp cosine? Cosine of what? 30 is going to be equal to force of friction. What's the equation for force of friction? Mu k times the normal force. I'm asked to find what F pull is. What is F pull in this equation that I've written? Fp. So I can solve this for Fp, divide both sides by cosine of 30, and plug in any other numbers that I know. I know mu k. What is mu k? Yep. So my Fp is going to be equal to mu k, which is what? 0.6. Fn, do I know what Fn is? No. Divided by cosine of 30. My goal is to get Fp. If I want to get Fp, what do I have to find? Fn. Can I find Fn? How can I find that? Let's see what's going on in the y direction. So I have the sum of forces in the y direction. What forces are acting up? Fn is acting up, the normal force. Any other forces acting up? F pull y. F pi. I like pi. Anything else acting up? Nope. Anything acting down? Gravity. And it's going to be equal to mass times the acceleration in the y direction. Where does this equation even come from? This is a law. Newton's law. Which of Newton's law? Second law. What is the acceleration in the y direction? 9.8. No. How fast is this thing moving in the y direction? Is it bouncing up and down as it's moving? Is it moving at all in the y direction? No, it's 0. Why is it 0? Because it's not moving in the y direction. Yeah. It's not always going to be 0. At some point, students always get to the level where it's always 0, that's why. No. Okay. What are we looking for here? What do we want to get? We want to get Fn. So let's get Fn by itself. Fn is going to be equal to Fg, add Fg to the other side, minus Fpy. So Fn, what is Fg? Mg. Fg is Mg. Chant it when you go to sleep. What's Fpy? Fp sine of 30. Okay, so now I have an equation for Fn, don't I? So I can take that equation and I can plug it in. And take that and plug it in to the previous equation that I had. So this goes right in there. So now I have Fp is equal to mu which is 0.6. We plugged in our numbers, didn't we? Yeah. 0.6 times Fn, which is mg minus Fp times sine of 30, all divided by cosine of 30. Ooh. Do I know what my mass is? Yes or no?
Yes.
What's my mass? 40 kilograms. Okay, so now I'm just plugging in all my numbers because you guys like to plug in numbers. What's my G? 9.8, positive or negative? Positive. When is G negative? When you're using those kinematic equations, it's usually negative. You already accounted for it right up here in the sum of forces. All right, minus Fp times sine of 30, all divided by cosine 30. All right, how many unknowns do I have in this equation? 2? 1? One variable on both sides. So what do I need to do? I need to do algebra. This is the point where I usually would have said, okay, now go home and do the algebra. Your request was that I solve problems all the way. So I will keep going just because I like you guys so much. Or maybe because I hate you guys so much. Okay, so the first thing I like to do when I'm doing algebra, I like to get rid of fractions. Fractions screw me up. Fractions, very easy to make mistakes. So to get rid of this fraction, I will multiply both sides by cosine of 30. This is by no means the only way to do this. Multiply both sides by cosine of 30. So that's going to get rid of the cosine 30 on the right-hand side and move it over to the left. So I have Fp times cosine of 30 is equal to 0.6 times 40 times 9.8 minus Fp times sine of 30. Okay, where do I go from here? Say that again? Divide both sides by 0.6, sure. Fp cosine of 30 divided by 0.6 equals 40 times 9.8 minus Fp times sine of 30. Here we need to get interactive. Somebody tell me, what is cosine of 30 divided by 0.6?
1.44.
Fp times 1.44. That 1.44 was dividing the cosine 30 by 0.6. Equals, what's 40 times 9.8? 392 minus Fp times sine of 30. I still have those Fp's on both sides. How do I get Fp's all on the same side? Yes?
Move the FP sine 30 over to the sine.
How do I do that? Add? I don't multiply? I don't divide? No, I just add. So I add Fp sine 30 to both sides. Again, there might be quicker ways to do this. There might be easier ways to do this. This is the longest, most brutally worked out way you could possibly do this problem. So these FPs cancel. Let's minimize this. And we'll find FP times 1.44. Somebody do me a favor. What's sine of 30? It's what? 0.3? 0.5. I should know that off the top of my head. Shame on me. Equals 392. Okay. What do I do now? I do what? Factor out of FPs? Sure. FP times 1.44 plus 0.5 equals 392. FP. What's 1.44 plus 0.5? What is it? Good, we can do math. I could do that one in my head. Equals 392. It's not often I can do things in my head. How do I get FP by itself? Divide both sides by 1.94. Hopefully we can all do that. I'm not going to write that down. FP is now equal to, what's 392 divided by 1.94? 202 newtons. Okay, there it is, worked out in all the gory detail you could possibly want. So chapter 6, problem number 54, is all about an amusement park ride called Dropout, where riders are spun in a circle of radius 6 meters, which pins their backs against an outer wall. When they're spinning quickly enough, the floor drops out and they are suspended by friction. If the coefficient of static friction between the riders and the wall is as small as 0.25, how many revolutions per second must the ride achieve before the floor is allowed to drop out? Oh gosh. So as usual, the first step is to draw the situation and draw all the forces that are acting. So let's draw this little circle thing that we have. And it's spinning around and around. But it's kind of a side view of the thing. So there's my person in the thing. My person's got a little bit of a badonkadonk here. A little extra butt. Okay. They're spinning around with their badonkadonk. What forces are acting on them? Gravity. Where does gravity go? Down. Gravity is pulling this poor, poor soul down to their deaths. Are they actually falling out of this ride? No. So there has to be another force that's acting up. What force is acting up? Somebody said normal force. I'm going to talk about normal force. Normal force is going horizontal. Why is the normal force going horizontal? It's always perpendicular to whatever surface you're touching. Okay? And then I think somebody else has said what force was acting up. What force was acting up? Friction. That's why that ride actually has a carpeted wall. The carpet increases the amount of friction that you have. So you have force of friction. Any questions on this? We can all draw this free body diagram. Okay, what other pieces of information have they given us in this problem? They give us the radius. What was the radius? 6 meters. So that's how big this circle is. That's 6 meters. What else did they give us? They gave us mu. And what is mu? 0.25. Did they give us a weight for this rider? Do they have a mass? No? That seems odd. Seems like something we'd need. Let's keep going. All right, what do we do when we have forces acting in different directions? Separate them into x and y. What forces are acting in the x direction? Sum of the forces in the x direction equals what? Normal force. Okay, any other forces? No other forces in the x direction? Okay, so that's got to be equal to the mass times the acceleration in the x direction. What's the acceleration in the x direction?
That'd be G force in the x direction. Just pushing you against the wall.
G force. So if we do an overhead view of this, then we have a circle, kind of. Our normal force is acting towards the center of a circle. What do we call forces that act towards the center of circles? Centripetal force. So what kind of acceleration do we have? Centripetal. Centripetal acceleration. So the normal force is providing some centripetal acceleration. So Fn has to be equal to the mass times the centripetal acceleration. So this is one of those situations where the acceleration isn't zero. Right? We're feeling some force, we're feeling some acceleration as we're going around in the circle. What's the equation for centripetal acceleration? Right, v squared over r. So Fn is equal to m times v squared divided by r. Okay, so I know what the F in force is. It's mv squared over r. Okay. Can I do anything else in the x direction? Anything else going on?
Doesn't there have to be something in the opposite direction, otherwise it'd be net movement towards the center of the circle?
Nope.
Or doesn't?
Nope. Because this thing is spinning. So the normal force is always changing direction. But it's always acting towards the center of the circle. The thing that's acting to keep them where they are is inertia. Okay. What's going on in the y direction? What forces, sum of forces in the y direction are acting? What's acting up? Force of friction. What's acting down? Gravity. What's the acceleration in the y direction? Acceleration in the y direction has to be 0. What happens if it isn't 0? Then they're moving and this carnival is going out of business. So force of friction has to be equal to Fg. What's the equation for the force of friction? Mu times the normal force. What's the equation for Fg? Mg. Okay. Do I have an equation for the normal force I can plug in? Yep. Where did that come from? Came from the x direction. So I take that x direction and plug it in. So I get mu times m times v squared divided by r has to be equal to m times g. Bless you. Is there anything I can get rid of? M is on both sides, isn't it? M goes away. So does mass matter on this ride? No. This is why anybody can ride this. No matter how skinny you are, no matter how fat you are, the physics will work. This is why carnivals like this ride. They can't get sued. They don't have to weigh people before they go on it. Sorry, you're too skinny, you can't ride. Sorry, you're too big, the force of gravity will pull you right down to your fiery death. Not going to happen. So now we can do mu times v squared divided by r is equal to g. I'm looking for the velocity that this thing is spinning at, how fast it has to spin so that this person doesn't fall out. How do I solve this for v? So I got to do algebra again, multiply both sides by r. That gets rid of my r on the left-hand side. I get mu times v squared equals g times r. Divide both sides by mu. Mu's cancel. I get v squared equals g times r over mu. Take the square root of both sides. I get v equals the square root of g times r divided by mu. What is g? 9.8 meters per second squared. What is r? 6 meters. What's mu? 0.25. Square root. What do I get for v? 15 meters per second. Do I really get meters per second? What happens with meters per second squared times meters? What do I get? Meters squared over second squared. What about mu? Where are the units for mu? Mu is unitless. So take square root of meters squared divided by second squared. You get meters per second. And I get 15 meters per second. Is that the final answer that I was asked to find? What was I asked to find? Revolutions per second. How do I convert a meter into a revolution? This is a conversion factor. So 15 meters per second. I need to figure out how many meters there are in one revolution. How many meters are there in a revolution around this circle? How do you trace the distance around a circle? What is that called? Circumference. What's the circumference of a circle? 2 pi r. Or pi times the diameter. Either one will work. So I need to do 15 meters per second times 1 revolution over 2 times pi times 6 meters. Meters will cancel, and I end up with my final velocity of 0.4 revolutions per second. That's a fun little problem. Any questions? No?